The SureServo 2 system natively has almost 17 million pulses per revolution. That's 24 bits of resolution. And unlike many systems out there, where if they do have 24 bits of resolution, it's only for a few select high-end expensive models. That's a key difference. Every SureServo 2 system has 24 bits of resolution. But since your general-purpose PLC typically can only send around 1 million pulses per second, it'll take almost 17 seconds just to rotate the shaft once, which is why we use electronic gearing. It allows you to adjust the servo system so it can be more responsive to your controller. The drive uses parameters 1.44 and 1.45 to do that. If you leave parameter 1.44 at the default, which is that 24-bit resolution number, then whatever you put in parameter 1.45 will be the number of pulses your controller needs to send to get 1 revolution. The SureServo 2 system refers to that as pulse user units, or PUU. For example, the SureServo 2 system defaults to 100,000 pulse user units, which means it should only take 100,000 pulses to rotate the shaft 1 revolution instead of 16 million pulses. So I set up a Brix PLC with a high-speed differential output module to send 100,000 pulses at 100,000 pulses per second to the SureServo 2 drive. So we would expect to see 1 revolution in about 1 second. I say about 1 second because it takes time to accelerate and decelerate. Yep, that was 1 revolution in about 1 second. Perfect. I'll send the same number of pulses but in the other direction, and we're back to where we started. If I change the gear ratio and double the pulses per revolution, oops, the drive's telling me I can't change the gear ratio while the motor's enabled. So I'll disable the motor, double the gear ratio again, and re-enable the motor. Now the 100,000 pulses sent by the controller only rotates the shaft halfway, exactly what we expect. And I'll send it back again. So with electronic gearing, you have control over how many pulses your controller needs to send to get 1 revolution of the motor shaft. But this isn't like a stepper. In a stepper system, when you change the pulses per revolution, you also change the resolution and accuracy to be that many steps. In the SureServo 2 system, the servo motor's encoder always uses the 24 bits of resolution. The drive automatically converts your controller pulses using the electronic gear ratio to get back to the native 24 bits of resolution of the motor and the encoder, which means you don't lose any resolution no matter what you choose for the geared down controller pulses per revolution. And remember, every SureServo 2 system has the 24 bits of resolution. And while having that incredible 24-bit resolution is great, it's important to understand that it's the SureServo 2's 3.1 kHz bandwidth that allows the current loop to give you a fast and efficient system response. So the 3.1 kHz bandwidth, coupled with the 24-bit resolution, is what makes the SureServo 2 system so responsive and accurate regardless of the gear ratio. One of the cool things about the SureServo 2 system is you actually have 4 gear ratios to choose from. You just configure any 2 digital inputs to select one of 4 gear ratios you specify in these parameters. A word of caution. Remember a minute ago the drive wouldn't let me change the gear ratio while the servo was enabled? That's because the new gear ratio takes effect immediately, which could potentially damage your system if you enter a wrong number, right? Well, these guys don't have that protection. The SureServo 2 system assumes that you've tested these numbers and they will work in your system regardless. So it'll let you change these gear ratios on the fly while the servo motor's running. But I'm still going to caution you against changing gear ratios on the fly unless you really know what you're doing and have thoroughly tested everything and know it's going to work. It's a powerful feature, but you'll need to be extra careful in using it while the system's running. If you get it wrong, you could really mess things up. Of course, it's an awesome feature if you just need to quickly switch process speeds between runs while the motor isn't enabled. And that's really all there is to electronic gearing for pulse train mode. Now, electronic gearing also affects position register mode. For example, I use the SureServo 2 Pro software to set up the motor to move back and forth between 2 positions, 1/2 rotation each way. There's a separate video showing you how to set up position register mode using the free SureServo 2 Pro software that you can download from the AutomationDirect.com website. If I disable the servo, then cut the gear ratio in half, then re-enable the servo and get the path running again, we see it's now rotating a full rotation for each move. Why? Because we told each move to go this many controller or PUU pulses. And since we cut the gear ratio in half, the same number of pulses goes twice as far. And position register mode can also use the 4 different preset gearings. And all the same cautions apply, so please be careful if you choose to change the gearing while the motor's running. Well, that ought to be enough to get you going with electronic gearing on a SureServo 2 system. Click here to learn more about the SureServo 2 system and to find more videos like this one. Click here to subscribe to our YouTube channel to be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning technical support options.